And just looking at what we have on page 333, and we have for item number 60. Okay, now we have a multi-part problem here, and we have concerning the rational function, whereupon we have x plus 4 over x minus 1. Okay, so in the case of number 60, okay, so you have a function r of x. It could be f of x, a of x. But I like to use r for rational functions, but it could be f of x. And here we have r of x. Okay, so you have x plus 4. We have all over x minus 1. And for what we have in the case of the rational function, okay, so if we set up a table of intervals, and I'm going to kind of go through this once again, just taking it in more step-by-step terms. Okay, so you have, looking for the zeros, okay, so you have x expressions in the numerator and denominator. Okay, so for x plus 4 equal to 0, okay, we have x equal to negative 4. And for what we have in the case of x minus 1, okay, so if I set this equal to 0, okay, so I have that x is equal to 1. Okay. All right, and now just taking what we have here. Okay, so you have a rational function. Now for the zeros. Okay, we have a negative 4. Okay, and negative 4 originates from x plus 4, which is in the numerator, and you can have a 0 numerator in the function as long as you do not also end up with a 0 denominator. Okay, so we have in the case of negative 4, okay, so that function, okay, that is going to be in the domain. So I'm just going to use shorthand here for ITD, in the domain. And we have 1, okay, and this stems from x minus 1, and if x is 1, the denominator is 0, and the rational function would be undefined. Okay, so we're still going to be using 1 in the case of the table setup, okay, but again, 1 is not in the domain. And so what we have in lining up, okay, so for the table of intervals, okay, so we have between negative 4 and 1, negative 4 is the smaller of the zeros. Okay, so you're going to have those values x less than negative 4. Then you have those values x greater than negative 4 and less than 1. And then we have those values x greater than 1. Okay, and so setting things up and creating partitions so as to be able to set up separate rows and columns. Okay, and we have upon initiating. Okay, so if we select tested values for the input, for each input. Okay, so we have for the first, anything less than negative 4 is going to be a value that is more highly negative than minus 4. Negative 5 is a possible choice. Anything between negative 4 but not including negative 4 or 1, okay, we have 0 as a choice. And anything greater than 1, okay, we can go with the number 2. And we have with the selection of the test values. Okay, so we have in this setup, again, we have with r of x equal to x plus 4 over x minus 1 So plugging in negative 5. Okay, so you have negative 5 plus 4 is negative 1. Negative 5 minus 1 is negative 6. Okay, so you're going to have a negative 1 to negative 6 ratio, and a negative over a negative becomes a positive. So we have the reduction here to be at 1/6. Now for r of 0, okay, so you have 0 plus 4 is 4, 0 minus 1 is negative 1. So you have positive 4 over negative 1, and that reduces to negative 4. And in the case of r of 2, okay, you have 2 plus 4 is 6, and 2 minus 1 is 1, and that reduces to positive 6. And with the sign of r of x, okay, anything in the input that is less than negative 4, the resulting output is positive. Okay, so we will have the r of x is greater than 0. Anything that is between negative 4 and 1, okay, the output is negative. So we're going to have the r of x is less than 0. And for anything that we have selected that is greater than 1 for the input, okay, so the output is positive. Okay, so you have the r of x is greater than 0. Okay, so we have the table set up. And for what we have in each of the parts. Okay, so for the first statement, now in my examples, okay, among the various inequalities, I had started out with less than 0, but part A, we have less than or equal to 0. And for what we have in the case of the solution, okay, so the function will be going in the same direction as less than 0. Now we have the limit values involved and to be grouped to be negative 4 and 1. Okay, now with the equal sign, there is the potential for there to be a bracket. Okay, and we can only enclose brackets around those zeros that are in the domain. Okay, so we have a negative 4. That was x plus 4 over x minus 1. So we have with the 0 at negative 4 is in the domain. So we have this in the bracket. 1 is not in the domain. So that stays in the parentheses. For x plus 4 over x minus 1 is less than 0. We have for the solution, we're still involving the limits negative 4 and 1, and since we have the inequality to be less than, there will be no brackets whatsoever. So both negative 4 and 1 are in the parentheses. Now in terms of changing direction, okay, now we have for part C, we're looking at where the ratio is greater than or equal to 0. And for what we have in the case of the solution, where we have greater than or equal to 0, so this will be in the same directions where r of x is greater than 0, and you have the corresponding limit values at negative infinity and negative 4, as well as 1 and infinity. Now for the enclosures, okay, now again, infinities are boundless, so we maintain the use of parentheses. Now with negative 4 and 1, and because they have the equal sign here, we could have a bracket in the midst, and negative 4 is in the domain of this function, so the negative 4 again causes the function to be equal to 0. Now for 1, on the other hand, it causes the function to become undefined as opposed to equal to 0, so that stays in parentheses. Now, for what we have in D, okay, this is just regurgitating the limit values where we're going to have parentheses throughout. So for x plus 4 over x minus 1 is greater than 0. Okay, we have, again, for the solution, again, you have, again, parentheses around negative infinity and negative 4, as well as parentheses around 1 and infinity. Okay, so these would be the solutions. So what we have among these inequalities compared to 0 with the rational function x plus 4 over x minus 1. Now, in the case of what we have with number 64, and we have for this item, the given function, okay, we have 2 minus x over x plus 6. Alright, and looking for the zeros. Okay, so if 2 minus x is equal to 0, and I isolate the x terms, I have negative x, and moving the 2 over, I have negative x equal to negative 2, and changing the signs, whether it's through multiplying or dividing by negative 1, okay, we're going to have the negatives to become positive, so we have the x is equal to 2. As for x plus 6 is equal to 0, we have the x is equal to negative 6. Alright, so we have, in the case of the rational function, once again, okay, so you have r of x is equal to 2 minus x all over x plus 6. Now we have with the zeros. Okay, so you have, so you're going to have 2, which is in the domain. Okay, so you're going to have 2, which is going to be in the domain. And negative 6, okay, so this stems from the denominator, okay, that one is not in the domain. Alright, now we're looking at solving for just one inequality statement. And just setting up what we have for the intervals. Okay, so we got those values x less than negative 6. We have along with those values x, okay, whereupon we have between negative 6 and 2. And for the rest of the set, we have those values x greater than 2. Okay, so for what we have in the case of values to choose for inputs, okay, so we have in the first, okay, we have for anything less than negative 6, okay, so we can go with negative 7. Anything between negative 6 and 2, okay, again, we can go with 0. Anything greater than 2, we can go with the number 3. Okay, so we have with our function, again, we have r of x, again, we have equal to 2 minus x over x plus 6. Okay, now for r of negative 7, we have 2 minus negative 7, so this will revert to 2 plus 7. And negative 7 plus 6 is negative 1. And we have for 9 over negative 1, okay, this will come out to negative 9. Now for r of 0, okay, so you have 2 minus 0 is 2, 0 plus 6 is 6, and 2 6 reduces to 1/3. And in the case of r of 3, okay, that one we have 2 minus 3 is negative 1, and we have 3 plus 6 is 9. Okay, so right away this is just going to be negative 1/9. Okay, now for the sign of r of x. Okay, so for any value plugged in for x less than negative 6, okay, we have the output to be negative. So we have the r of x is less than 0. Anything selected between negative 6 and 2, the output is positive. So you want to have the r of x is greater than 0. And anything selected that is greater than 2 for the input, the output is going to be negative. Okay, so you have the r of x is less than 0. Now, in the case of what we have for the inequality, okay, we're looking at where 2 minus x over x plus 6 is greater than or equal to 0. Okay, so in essence, okay, you're looking at where r of x is greater than or equal to 0. Okay, so we're looking at the direction to be the same as where r of x is greater than 0. So looking at what we have here from this middle column going up, okay, we have our limit values involved to be at negative 6 and 2. Okay, and since the nature of the inequality has the equal sign, okay, there could be a bracket, and it'll be around that 0 or zeros that will be in the domain, and 2 is in the domain. So that is going to be in the bracket, okay, but for negative 6 on the other hand, okay, that one is not in the domain. Okay, so there will be a parenthesis around that one. Okay, so that would be the interval solution for what we have in the case of number 64. Now, for what we have in the case of 80, now we have a comparison inequality that is set up where we have a comparison between rational functions. Okay, and now for what we have in the case of number 80, okay, we're looking at working with not the variable x, but z. And in the case of number 80, okay, we've got 2 over z minus 1 is said to be greater than negative 4 over z. All right. Now, if I rewrite this inequality and partially translate as a comparison to 0 inequality, I can move this 4 over z by adding to both sides. Okay, and so we're going to have 2 over z minus 1 plus 4 over z, okay, is greater than 0. And if I look at putting together these ratios, okay, so we got just working on the side here, we have 2 over z minus 1 plus 4 over z. And I want to put these expressions together. Now we have the least common denominator. It's going to be z times the quantity of z minus 1. Okay. Now for the first ratio, if I put this in the context of the least common denominator, okay, so I already have the z minus 1 part, but it is missing the z portion. So for 2 over z minus 1, okay, this ratio is going to be multiplied by 1 in the form of the missing term z all over itself. And for the second ratio, it's going to be the reverse scenario. Okay, this ratio has a z part, but it is missing the z minus 1. So for 4 over z, this will be multiplied by 1 in the form of z minus 1 over itself. So looking at what we have in the setup. Okay, again, we have in the denominator, okay, we have z and z minus 1. Product of the numerator terms will be 2z. We have for the second ratio, okay, this will be in with the least common denominator now in formation, okay, and we have for 4 over z minus 1. I can go ahead and distribute, so this will be 4z minus 4. And once I look at consolidating, okay, so both of these ratios are with z and z minus 1 in the denominator, and combining the numerators. Okay, so I have from the first fraction, I have 2z, and from the second, I have 4z minus 4. And since I have the linking operation to be addition, okay, there's no sign change that will be involved in the numerator of the second fraction. Okay, so I still have plus 4z minus 4, and combining, okay, so I have 6z minus 4 all over the quantity, okay, of z times the quantity of z minus 1. And so we have in combining these ratios, okay, so this comes down to 6z minus 4 all over z times the quantity of z minus 1 is greater than 0. All right, so we got in this case, okay, we have in the formation, you're looking at essentially where your function, and we'll just call this r of z, is greater than 0. Okay. Again, so you have r of z is equal to 6z minus 4 all over z times the quantity of z minus 1 and just taking what we have for establishing the zeros. So 6z minus 4 is equal to 0. We have that 6z is equal to 4. So you have z is 4, 6, and 4, 6 is reducible to 2/3. And we have from the denominator, okay, already have that z is equal to 0. And for z minus 1, if that is equal to 0, so I have that z is equal to 1. Okay. So we have in the setup, okay, so again we have r of z, the consolidated ratio. I'm just going to restate this. Okay, so you have r of z is equal to 6z minus 4 all over z times the quantity of z minus 1. Now for the zeros, okay, now we have 2/3 stems from 6z minus 4, which is only in the numerator. So 2/3 is the zero of only the numerator portion. And so that one would be in the domain. But now with the nature of the inequality, as it is, okay, whether it's in the domain or not, it's not an issue. But 2/3 would be in the domain. And 0, this stems from z, which is in the denominator. So that is not in the domain. And same thing for 1. This comes from the denominator factor z minus 1. Again, so we have not in the domain. Okay. All right. So just setting up a table of intervals. Okay, so you have among the zeros. Okay, so I have the smallest of the zeros, okay, happens to be 0. So the first interval we have between negative infinity and 0. Then we have next in line we have between 0 and 2/3. After 2/3, okay, we have 1. And for the rest, okay, we're going to have those values z that are greater than 1. Okay, so we have with the inputs. Now we're working with the letter z. Okay, so for anything less than 0, okay, we can go with -1. Anything between 0 and 2/3. Now I cannot select an integer, okay, and something between 0 and 2/3, we'll say 1/3. And between 2/3 and 1, same predicament, okay, I cannot select an integer. Now 2/3, say if you have as a decimal, this would be like very close to 0.67, something between that and 1. We'll say we have 7 cents, or put in decimal form 0.7. Anything greater than 1, okay, we can go with the number 2. Okay, so we have with r of z, okay, we have 6z minus 4 all over z times, okay, the quantity of z minus 1. Now for r of -1, okay, so I have 6 times -1 is -6 minus 4 is -10. Then we have -1, and we have -1 minus 1 is -2. -1 times -2 is going to be a +2. So for r of -1, okay, this will reduce to -5. Now for r of 1/3, okay, so you have 6 times 1/3 is going to be 2, minus 4 is -2. And we have 1/3, and 1/3 minus 1 is -2/3. 1/3 times -2/3 is going to be a -2/9. Okay. And if you notice, you have a negative to negative ratio, so that's going to be positive. And just for the follow through, okay, so I got 2 at the top, and if I divide by a fraction, it'll be the same as multiplying by the fraction's reciprocal. And so this will come out to +9. Now for r of 0.7, okay, you have 6 times 0.7 would be 4.2. Take away 4. So right now we're going to have 0.2 and 0.7, and you have 0.7 minus 1 is going to be -0.3. And the product of 0.7 and -0.3, that's going to be a -0.21. Okay. So right now we're going to have a negative fraction between decimals. Okay, but I can make adjustments here. Okay, so I can do here is that just to line up and have as many decimal places between the decimals. Okay, I can just add 0 to 2/10, so we have 20/100ths. And just move the decimal point 2 places to the right. And for this outcome, we're going to have -20/21. And in the case of r of 2, okay, you have 6 times 2 is 12. 12 minus 4 is 8. And we have 2 times 2 minus 1. That's 2 times 1, so that'll be 2. And that is going to reduce to +4. Okay, for what we have in the case of the sign of r of z, okay, anything negative that is selected for the input, the output is also going to be negative. So we're going to have the r of z is less than 0. Then we have next, okay, have a positive output. So we have the r of z is greater than 0. Next we have a negative input. So we have the r of z is less than 0, and then we have in the last, okay, we have the r of z is greater than 0. Okay. And okay, so for what we have originally, okay, so this is the inequality we started out with. Okay, so we had 2 over z minus 1 is greater than -4 over z. And, okay, so after consolidating, again, the ratios and comparing to 0, okay, so this boils down to where we have r of z is greater than 0. So we have for the solution, where we have r of z is greater than 0, this will be with the second and last interval sections. Notice we do not have an equal sign, so we're going to maintain the use of parentheses. Okay, so you have those values z between 0 and 2/3 still in parentheses, and you have those values z that will be greater than 1. Okay, so that will be the results in this case. Now, let's say that just as hypothetical, okay, if this had been whereupon we had the comparison to be such that 2 over z minus 1 is greater than or equal to negative 4 over z. Well, you would have a comparison to 0 where we would have r of z is greater than or equal to 0. Okay, now for the solution, now you're still working with the same limit values, but you might have brackets as well as parentheses. So just kind of going back to the setup here in terms of how 0, 2/3, and 1 and infinity will be grouped. Okay, so infinity is boundless, so the infinity stays in the parentheses. Okay, now in terms of what we have with the remaining grouping symbols. Okay, again, you have a bracket around those zeros. That will be in the domain. So if you notice, 0 and 1 are not in the domain, 2/3 is in the domain, and that would be the only element that would cause this ratio to be equal to 0. So 2/3 will be bracketed, whereas with 0 and 1, this will cause the rational expression to become undefined. So we still have a parenthesis around 0 as well as 1 around 1. And this would be the solution if your inequality had been along the lines of greater than or equal to. Now, just want to mention for the inequality portion, and we'll go ahead and look over these items. Now I had sent out a test 3 review set of items, okay, and it's got test 3 review number 5. And to what? If we go ahead and look into the, say, the inequality portions, okay, just sort of taking a composite summary, and we have with 15 through 19, okay, and we've got, say, in the case of 15, so it says here to graph the solution to the following inequality on a number line. Okay, so you have x squared minus 2x is greater than or equal to 8. And for this one, so we have for 15. Okay, so if we're looking at solving for x in this one, okay, so you have x squared minus 2x is greater than or equal to 8. And just rewriting what I have as a comparison to 0 inequality. Okay, so we have x squared minus 2x minus 8 is greater than or equal to 0. So in essence, okay, you have it where f of x is greater than or equal to 0. Now, if we look at determining the zeros, okay, so for x squared minus 2x minus 8 is equal to 0. So in 15, we're back to not a rational, but a polynomial inequality. And if we look at factoring, say the quantity of x plus 2 times that of x minus 4 is equal to 0. And if x plus 2 is equal to 0, okay, so you have x is equal to negative 2. And for x minus 4 is equal to 0, okay, so we're going to have the x is equal to 4. Okay. Again, so we have f of x is equal to x squared minus 2x minus 8 Now this function would have all real numbers for the domain. Okay, so like -2 and 4, those have set the function equal to 0. There's no way that it could set the function undefined or as undefined. Okay, so you have the zeros at -2 and 4. Okay. And just in the case of the creation of intervals. Okay, so between -2 and 4, -2 is the smaller. So we have those values x less than -2, and then we have those values x between but not including -2 and 4. Then we have those values x which will be greater than 4. Again, we're testing out the inputs as we apply the polynomial function f of x is equal to x squared minus 2x minus 8. Okay, so for the test value inputs we can supply, okay, anything less than -2, we can go with -3. For the spread between -2 and 4, for the integers, I go with -1, 0, 1, 2, or 3. We'll just go with 0. Anything greater than 4, we can go with the number 5. So for f of -3, okay, so first term, I have the square of -3. I have -2 times -3, minus 8. -3 squared is a positive 9. -2 times -3 is a positive 6. I have minus 8, and 15 minus 8 is a positive 7. And for f of 0, okay, variable terms will be rendered negligible, and so f of 0 is going to be at -8. And for f of 5, okay, so you have x squared, so this will be 5 to the second. We have -2 times 5. We have minus 8. Now 5 squared is 25. -2 times 5 is -10. Minus 8, and 15 minus 8, this will come out to a positive 7. And for the sign of f of x, okay, so anything selected for the input that is less than -2, the output is positive. So we will have f of x is greater than 0. Then for the next, we have a negative output, so we have f of x is less than 0. Then for the last, I have a positive output again. So we have the f of x is greater than 0. Okay. Okay, so we have in the case of the solution. Okay, so we started out with x squared minus 2x is greater than or equal to 8. Again, we have f of x is greater than or equal to 0. So this will be in the same direction as f of x is greater than 0. So in the case of the interval solution, okay, so we have between negative infinity and negative 2. And negative 2 sets the function equal to 0. So that is going to be in the bracket. And then we have the other part. We have starting from and including 4. We have heading on out to infinity. Okay, so again, infinities are boundless. So we still maintain the use of parentheses. Okay, now in terms of, let's say, just the graphing. Okay, what's going to happen here is that we have with our limit values of negative 2 and 4. Okay, so on negative 2, okay, we have this value included, and likewise 4, okay, that is also included. And just for the activity, from negative 2, you have an array that's going to go continuously to the left. Then we have tending to negative infinity. Then we have values of x greater than or equal to 4. So from 4, from which we have a solid point, okay, we have an array that's going to go continuously to the right and approaching positive infinity. So this is your interval solution, and that immediately below is going to be the graph solution. And again, the brackets indicate that on the graph, okay, you have the inclusion of both negative 2 and 4 indicated by either brackets on the graph or as Alex would have it, solid points. All right, now for the case in the next item, now we have an inequality that is presented in factored form. So here we have x plus 2, x minus 4, and x plus 6, for which the product is greater than 0. Okay, so you have x plus 2 times the quantity of x minus 4 times that of x plus 6 is greater than 0. Okay, so we already have the inequality expressed in terms of comparison to 0. And again, if I were to set x plus 2 times x minus 4 times the quantity of x plus 6 equal to 0, so you have with our factors. Okay, so if we have x plus 2 is equal to 0, we have the x is equal to negative 2, and with x minus 4 equal to 0, so you have the x is equal to 4, and with x plus 6 equal to 0, so we have the x is equal to negative 6. Okay, so again, we have with our function. Okay, so you have f of x, you have the product of x plus 2, x minus 4, and x plus 6. Again, we have with our zeros. Okay, so you have negative 2, 4, and negative 6. Okay. And looking at just setting up a table of intervals. Okay, so you have between negative infinity and the smallest of the zeros is negative 6, Then we have bypassing -6 and proceeding past -6, approaching the next smaller zero. So in this case, we have -2. Then we have between -2 and 4. The last interval section will be in reference to those values x greater than 4. And just setting things up here. Okay, so we have upon separating the interval sections and also the categories, okay, along each row. Okay. So we have among the input values that we can apply. So for the test value x, okay, so we have for anything that is less than -6, okay, we can select -7. Between -6 and -2, we can go with, say, -3. Between -2 and 4, 0 is a possible choice. And for anything greater than 4, 5 is a possible choice. Okay, now we have with the test values. Okay, so we have with our numbers. Okay, so if I work with 0 first, it's got 0 plus 2 is 2. 0 minus 4 is -4. And 0 plus 6 is 6. So for this product, we're going to have a -48. In the case of f of -7, okay, so we have -5. -7 minus 4 is -11. -7 plus 6 is -1. So we got 55 times -1, so the product is going to be -55. For f of -3, -3 plus 2 is -1. -3 minus 4 is going to be a -7. -3 plus 6 is a +3. So we're going to have 7 times 3. So the product is going to be a +21. In the case of f of 5, okay, 5 plus 2 is 7. 5 minus 4 is 1. And we have 5 plus 6 is 11. Okay, and so we have 7 times 11, so this will be a +77. So for what we have among the sign values, okay, so we have a negative, okay, so you have f of x is less than 0. Next you have a positive. So you have the f of x is greater than 0. Next we have a negative, so we have f of x is less than 0. And then we have a positive, whereupon we have f of x is greater than 0. Okay, so for what we have in the case of the inequality, let me get this stuff. See what I'll do here. I'll just move this. It's not quite doing what I want it to. Okay, so where we have f of x is greater than 0. So you have, for the solution here, okay, so where f of x is greater than 0, okay, so we have limit values involved. Okay, we have between -6 and -2. So you have in parentheses. And also where we have f of x to be greater than 0, okay, we have for those values of x between 4 and infinity. Okay, so that would be the interval solution for what we have in the case of this problem that we have for number 16. All right, now taking what we have in the case of the next item, and we have for number 17, okay, so we got the square of x plus 4 times the quantity of x minus 6 is less than 0. And just double checking here, so that was less than 0. Okay. Okay, so for what we're going to have in the setup, okay, so you have your f of x is equal to the square of x plus 4 times the quantity of x minus 6. So we have a direct polynomial expression, and the zeros involved will set the function equal to 0. So you have with the zeros from x plus 4, we'll have -4. And for x minus 6, I have x equal to 6. And for what I have among the intervals here, so we have values of x less than -4. You have those values x between -4 and 6. Then we have those values x greater than 6. Okay. Okay, so for what we have in the case of f of x equal to the square of x plus 4 times the quantity of x minus 6. Okay, so among the tested values, anything less than -4, we go with -5. Between -4 and 6, we'll just go with 0. Anything greater than 6, we'll just go with 7. So we have for f of -5, okay, so we have -5 plus 4 is -1 which will be squared. Negative 5 minus 6 is going to be negative 11. Negative 1 squared is going to be positive 1. We had times negative 11, so that product or output, okay, this is going to be negative 11. For f of 0, we got 0 plus 4 is 4, which will be squared. 0 minus 6 is negative 6. 4 squared is 16 times negative 6. And we have for that output, okay, we have at negative 96. For the case of f is 7, okay, you have 7 plus 4 is 11. 7 minus 6 is 1. 11 squared is 121 times 1. Okay, so we have that output. Okay, that is going to be a positive 121. Now for the sign of f of x. Okay, we have for values of x less than negative 4 for the input, the output is negative. So you have the f of x is less than 0, and for anything greater than negative 4 but less than 6 for the input, the output is also going to be negative. And then for anything selected for the input greater than 6, the output is positive. Okay, so you have the f of x is greater than 0. Okay. And so for what we have for this inequality, okay, so you have the square of x plus 4 times the quantity of x minus 6 is less than 0. So again, we're going to be looking at referencing where f of x is less than 0. And guess what? For the interval solution, okay, and we have for the first two sections, we have the f of x is less than 0. So you have involving values of x less than negative 4, along with those values of x greater than negative 4 and less than 6. Okay, so that would be your solution. And let me just throw this in. If the square of x plus 4 times the quantity of x minus 6 is less than or equal to 0, what's going to happen here is that you're still looking at the same limits, since less than or equal to is the same direction as less than. Now negative 4 will cause the function to be equal to 0 as well as 6. So negative 4 and 6 would be bracketed. Okay, but now we got the right grouping symbol so far, but we don't have quite the final answer again, because negative 4, there was like a gap between these two interval sections, but now with negative 4 included, these sections will be joined as one. So it's going to turn out that for the whole solution in this one, and to make it as a complete finalized statement, so you're going to have those values that will be less than or equal to 6. So your interval solution, instead of two separate ones, thanks to negative 4 being included, okay, your solution is going to be those values of x less than 6. Okay, so you just have that one consolidated statement. Okay, and was going to mention. Now, for the case that we have for number 18, okay, so we have in this one, okay, so you have x plus 4 over x minus 7, okay, is less than or equal to 0. Okay, so for your function r of x, you have equal to x plus 4 over x minus 7. Now for the zeros on this one, okay, so we have from x plus 4, I have negative 4. And since the corresponding factor stems only from the numerator, and since negative 4 sets the rational function equal to 0, negative 4 is in the domain. Whereas we have from x minus 7, we have 7. And if I set x minus 7 to 0, instead of having the rational function equal to 0, again, it will be rendered as an undefined expression. So 7 is not in the domain. Okay, so if I set up intervals, you have those values of x less than negative 4. You have those values x between negative 4 and 7. Okay, we have those values x, okay, which will be greater than 7. Okay, and so looking at putting in a table, okay, so for selection of input values, so anything less than negative 4, we can go with negative 5. And we have anything between negative 4 and 7, okay, so we can go with 0. Anything greater than 7, okay, we can go with the number 8. Again, we have with the rational function. Okay, so again, we have x plus 4 over x minus 7. Okay, so we have an r of negative 5. Okay, so we have negative 5 plus 4 is negative 1. Negative 5 minus 7 is negative 12. And a negative over a negative becomes a positive. So the output will have a positive 1/12. Now for r of 0, okay, have positive 4 over negative 7. So this will come out to negative 4/7. In the case of r of 8, okay, so you have 8 plus 4 is 12. 8 minus 7 is 1. And 12 over 1 is 12. So that's going to be a positive number. And in the case of the sign of r of x, okay, so for the first interval section we have a positive output, next we have a negative, and last we have a positive. Okay. All right. And again, we have with the inequality. Okay, so that one was said to be less than or equal to 0. So again, we're referencing whereupon r of x is less than or equal to 0. And for what we have in the case of the solution, okay, so you have the same direction as r of x is less than 0, so we are involving the limit values, -4 and 7. The equal sign means that we might have a bracket, but no guarantee. Okay, so for -4, that one is in the domain. Okay, so that is going to be in the bracket. And with 7, again, that would render the rational expression as undefined since we cannot have the 0 denominator. The 7 is not in the domain. And so you're going to have a parenthesis to enclose the 7. Okay. And now, just items here. I tell you what, I'm kind of just going to make just a quick mention of what we have for number 19. Okay, so you have x plus 8 over x minus 1 is greater than or equal to -2. Okay, and if I consolidate, ultimately, okay, so I have x plus 8 over x minus 1 is greater than or equal to -2. And if I convert what I have here as a comparison to 0, inequality, okay, so I have x plus 8 over x minus 1 plus 2 is greater than or equal to 0. And just kind of like what I had with the variable z earlier, I'm going to be looking at combining these expressions into one. So you just look at this as x plus 8 over x minus 1 plus 2 over 1. Now, least common denominator, again, that's just going to be x minus 1. So I already have the x plus 8 from x plus 8 over x minus 1. That already has the least common denominator. And for like 2, I can write as 2 over 1. And just multiply by 1 in the form of x minus 1 over itself. And just piecing together ultimately. Now we have with 2 over the quantity of x minus 1, that is going to be 2x minus 2. And we have all over x minus 1. Now we got the operation of addition, so there'll be no sign change manipulation regarding the second numerator terms. And once I link together, so you have x plus 2x becomes 3x. 8 minus 2 becomes positive 6, and so we'll have all over x minus 1. Now I'm going to finish with just the setup. Okay, so right now, okay, we have, letting this be our r of x. So r of x is greater than or equal to 0. So for what you're going to have, at least in the setup, you have r of x is equal to 3x plus 6 over x minus 1. Now for your zeros. Okay, if 3x plus 6 is equal to 0, 3x is equal to negative 6, and with division by 3, your x value is going to be at negative 2. And this one is going to be in the domain. And with x minus 1, we have x is equal to 1. And since x minus 1 is in the denominator, now the 0 value of 1, okay, that one is not in the domain. Okay. And we'll be discussing the setup on this one. So